Thank you very much. Thank you very much for giving me this opportunity to chat with you today. And thanks for the nice introduction. Yeah, I organize a lot of events, all dead due to COVID-19. So it was a year where I guess I was supposed to organize about 3 or 4 in-person conferences in Linz, the first TypeScript conference of Europe, which was scheduled for March 31. So yeah, that didn't happen, but lots of other things did happen. So instead of doing lots of conferences, I decided to do this one. TypeScript in 50 lessons. So all my nights I spent writing a book. But anyhow, yeah, I'm Stefan Baumgartner. This is the first time I try doing slides like this. So let's see how it turns out. And since Ferdinand already asked me if I'm well prepared, it's great if you do markdown slides in a source code repository, but once you check them into Git or GitHub and you have GitLens activated, you can totally see how well prepared I am, because this slide has been changed 5 minutes ago. But hey, there's lots of examples here today and lots of code that I want to share with you. So let's dive in. That's me. You've seen me. You can see me right now. That's my book. We've already showed it to the camera. And I think it's kind of funny that I have written a TypeScript book, because when I was originally confronted with TypeScript, I didn't like it at all. In fact, I even hated it. And this is mostly because TypeScript came to me in what I call the 3 waves. The 3 waves where I was confronted with TypeScript. Excuse me. The first one was directly after its release around October or November 2012. It was so quite some time ago, about little more than 8 years, where some Java devs in my company said, now I found a way to write JavaScript. Look at that. And then they showed me all those abstract classes and interfaces and all that Java-ish syntax that has been thrown on top of a programming language that I actually like to use, and one that I actually enjoyed using. So they tried to Javaize this one programming language that I cherished so much. And this is why I totally was pulled off of TypeScript. It was like, okay, what CoffeeScript, how CoffeeScript tried to make Ruby work with JavaScript, they tried to make Java work with JavaScript. And this is something that I couldn't stand, so I ditched it. And then the next wave came, funnily enough, with Angular. So this was back in the day when Angular 2 was still a release candidate, and they had some very curious TypeScript settings there. So this was also the time where TypeScript really hit the mainstream. So this is also what the team says. The moment Angular decided to go with TypeScript, they could really see a spike in interest, in downloads, in visits on the web page, in issues that have been created on GitHub. So this was the moment where TypeScript reached mainstream. But with the settings that were back in the day, with maybe it's just with the boilerplate or with that one particular starter project that I had, they were very strict. So I needed to type everything. And there was this one particular situation where I was about to call the HTTP service for a request. And TypeScript told me, yeah, cool that you want to do a request with the HTTP service, but what data are you expecting? And I was like, how should I know? I haven't console logged it yet. This led me to what I call Michael Jackson TypeScript development. You argue with the compiler, are you okay? Are you okay? Are you okay? And yeah, I don't know if you know the song Smooth Criminal back from the 90s. That's how I developed TypeScript. And I was like, okay, this is not how I would write TypeScript, how I would want to write JavaScript. There was so much maintenance going on. I needed to know so much about everything that I was supposed to do, which was just not the style I was writing web apps, JavaScript apps. But hey, I was wrong. I was very, very wrong. TypeScript actually, and this was the third wave, is way, way closer to JavaScript than I thought. And this is a classic case of having the wrong approach, or being biased, or seeing just a couple of things in source code and immediately draw connections to stuff that I don't like. TypeScript itself is just what they say on the paper. It's a superset of JavaScript, and you can reduce all the features of TypeScript to just have a thin layer on top of JavaScript. Of course, you can use all the additions from the programming language that you have, like enums or abstract classes or whatnot. Namespaces, I guess, is also something that is still around, but you don't have to. You can stick to writing JavaScript and just add enough type information so TypeScript understands your JavaScript code better. And this is an approach that I can get along with. One person that really evangelized this approach was no other than one of TypeScript's inventors, Anders Heisberg. I don't know if you heard about him, but this person practically defined the last 4 decades of programming. So Turbo Pascal in the 80s, Delphi in the 90s. If you ever written a Windows 3.1 application with the tools that Microsoft gave you, which was the Win API in C, you really know how important it was to have a drag and drop UI tool in the 90s to create Windows UIs. And this was also the work of Anders Heisberg. Then C# in the early 2000s, and now in the last decade TypeScript. And if you want to do yourself a favor and you don't find anything on Netflix, Disney Plus, or wherever, try to find his keynotes on TypeScript that he gave at Microsoft Build, where he really tried to give you the information how the TypeScript team works. That they're closely tracking the ECMAScript standard, they're closely working with standards, and they really try to be the tool that catches all possible scenarios that there can be in JavaScript. He once said it at his keynote from Microsoft Build, I guess it was 2015 or something, where he said, it's not that JavaScript has no type system, there's just no way to formalize the type system. And this is TypeScript's role. And this is how the team right now decides to work on TypeScript. So all the language features that have been added in the early days, because let's face it, there has not been much of a language in the early 2010s. So we didn't have error functions or destructuring and all those niceties that make JavaScript such a nice language. We had to rely on transpilers that added language features. So they did a lot of invention there, but stopped the moment they saw there is some traction going on in the ECMAScript standard. And now they adhere to the ECMAScript standard. And every new language feature that you find in TypeScript will land in browsers sooner or later. And the innovation happens only in the type layer. This also led me to a series of blog posts which I call Tidy TypeScript, which is mainly about getting rid of all the craft around it that you actually don't need, and just work on the type layer and write nice types. But that's not what it's about today. Today it's about this one particular point where TypeScript is a tool to formalize JavaScript's type system. To be that close to TypeScript, to JavaScript, TypeScript actually added a ton of tools that help you writing JavaScript style, but giving you enough tools and possibilities to formalize types so TypeScript can understand your code better. One thing that I love, for example, is inference. Type inference is something that I can't value enough, because why should I type something explicit if it stands already there by having the value in plain sight? So inference is your friend. And with tools like generics and conditional types, you can define behavior and navigate in the type space. So you really have to write not that much types, just a couple, and let the type system and TypeScript figure out the rest. And the goal for us is to write types or create types that require low maintenance. So what do I mean with low maintenance types? Well, I guess the best would be to show it to you in a couple of examples. So I prepared 3 examples where I want to get your mind set on low maintenance type development. And let's start with the first one. So this is something that you maybe have seen. Those are some default options. I write a const object with default options. This is for a copy function where I want to copy files from a source to a destination. And usually to add proper types, I would write type options. This is basically, if you take a look, this is just mirroring what you have here in JavaScript, mirroring it to TypeScript, to the type system. One indicator that you are in type system in this layer around TypeScript, not in JavaScript itself, is of course this one particular type keyword. So here I have the function that copies stuff, whatever it does. I can add the type here. You all know that. That's something that you did, I think, plenty of times. And inside this function, I would then merge the options with the default options, and then I have a proper set of options that I can work with. So this is something that you see every day. But now the maintenance starts. So let's say I have more options than just from a test. I want to have a write mode, which is in that regard, it's override stuff. And here I have to maintain it. So I have to add the same information that I have in default options already. I have to add it again. Maybe I do a typo just like right now, and suddenly my code doesn't work anymore. So this is something that I want to avoid. And for that, TypeScript gives you a really nice way of doing that. And this is something that I actually, when I prototype, and I'm not sure how my type should look in the end, and when I'm in this evolutionary way of creating programs where you just figure out how your program should behave for data that you need, how the process should look like, this scripting style of programming, which comes in really, really handy and which I use all the time, which is adding just type of, and then add any field that you have in the code. So I can call type of default options. And what TypeScript does is finding out what stands here in default options, inferring the types, and saving it here in the options field. So this is one maintenance that I have that I can get rid of immediately by just adding this type of keyword. And this is also borrowed from JavaScript. It's if I had a const X here that is type of default options, I get one of those possible types in return. So this identifier is borrowed from JavaScript, the programming language, into TypeScript, the type system. It should mirror the same way of dealing with those things, but you are in a different level, in this one thin layer on top of it. So that's that, and I can add options back there. But of course, this is not everything. So the moment I call copy with whatever, and here's a file name, main.ts, for example, I see that I get compile errors because I would have to specify from test and write mode all of those, and this is not the sense of having default options. If I then have to specify all the options anyway, I need partial options. So this is something that I prepared here, where you just have this question mark, which makes this one property optional. So what I actually would need is partial options. But then I again lose the connection to default options. And this is where we can start working with generics and can work with possibilities that we have in the type system. So one thing that we could do, for example, is create a type that is called optional. This is one of those utility types that we're going to see a lot today. It's a generic, which means it takes a generic variable. So it's important that I call the generic variable because those generic types work a little bit like functions. So what TypeScript did there is creating their own functional programming language on top of the type system, and we can do a lot of fun with that. So hang around. And I just accept any object in there, and I want to go over all its keys. So I create a new object, and then I say, okay, for every key in the keys of T, okay? So what it does is every key that it gets, it iterates over it, add a type modifier, add this question mark that I have from those partial options, and then access the original type at this particular position. There's a column missing. Okay, and with this optional T, let's do a debug type right there. With this optional T, I can say optional of options, and you see that no matter what I add in the default options, I get this question mark attached to it. Actually, I don't need to write that. This is already a predefined type. which is called partial. And with partial type of default options, I can achieve just the same thing. So I can pass an empty object, or I can pass, let's look at the autocomplete, I can pass a different destination, which is not dist, but destination, you know, and a different write mode, which is just write, okay, to it. And it works just like that. The only type that I have to maintain, well, none. I don't have to maintain any type at all. I just have to maintain this default options object. And the moment I decide that it's not test, but to, because I copy from to, I already get all the editor support that I need. So I can immediately refactor or find errors within my code. And this is what I mean with low maintenance type development. I don't have to maintain any types. I don't have to move around in my code and see if I carried along all the changes. I define the type once, and then I opt in for behavior. I try to define the behavior around it. So let's change it to 2, because I just can't stand red squiggly lines in my code. Okay, that's the first example. If you ask yourself what this monkey with the eyes closed is about, this is my cheat sheet. If I forget something that I'm going to show you in my live coding session, I can always take a peek. Okay. So first example, next example, and this is something where I think stuff gets really, really funny. You probably have done something like creating union types and intersection types. So this is one thing in TypeScript where you can create very elaborate subsets of all the values that there can be in JavaScript. So you can think of TypeScript as the sea of all possible objects, all possible strings, all possible numbers. And what you then do is creating little borders around those values. Like, okay, these are all the strings. These are all the numbers. Here we have all the objects. Here we have all the objects that follow a certain shape, like this shape of tech event base that you can see here. And then we can narrow down this set of all objects that follow tech event base. And this is something that I do here. So I want to maintain types for different styles of events. We are talking about events already. This is something that every event needs, like a title, description, date, capacity, how many people can attend, how many people have RSVP to it. And then I want to create a conference. And a conference happens at a location. It has a certain price attached to it. There is a number of talks. So talk is again some object that I defined. Don't worry about it. And it's of kind conference. And then I have a meetup. A meetup is usually free. And other than that, it also requires the same things that a conference does. And to combine this base with all the difference that I have between all the subtypes, I use an intersection type. This is this ampersand here. You can think of having an interface and creating a new interface that extends from an earlier interface. This is very similar to that. Actually, it's the same if you write TypeScript. There are a couple of nuances if you work with interfaces, but you could do the same, like type conference extends tech event base, or interface conference extends tech event base, and then you add the stuff that you want to change. So we have a conference, we have a meetup, we also have a webinar, and then we have all the possible tech events. Okay, this is then a union type. So the moment we narrow down all the values, like we became smaller in the set of possible values that we have, then we widened it again because we said, okay, it can be a webinar or a conference or a meetup. It has to be one of those. In the terms of the type space, all the properties that are the tech event has. So I have here a little function foo. If I look at event dot, I can see all the properties that this particular type has are all those properties from tech event base, because in all the other properties, they differ somehow. One property that has been added though, as opposed to tech event base, is kind, because we not only have a union type, we have a distinct union type. And the distinct union type is very, very special, because if you realized, kind is not the string, it's the literal value conference. So if you have the set of all possible strings that are available in the type space, in the type system, then conference is just this one particular string. So it's not possible that you have any other string at kind. You just can have conference or meetup or webinar. It has to be one of those three strings. And with that, we can, the moment we created those distinctions, you know, all those three types that tech event can take, we can narrow it down to a particular concrete subtype that we've created. So at the moment, we just have tech event, but thanks to event.kind, I have a switch statement here. I can say case, and then I get also autocomplete for all the possible cases that it can get. It can be conference, it can be meetup, it can be webinar. The moment I say webinar, event gets all those properties from webinar. So I have the URL here, for example, a property that I didn't have before. Now I have it available. So I can say something with event.url. Then I have conference, which is also a possible value of event.kind. And the moment I go to conference, I have case conference. Sorry, break. I guess I have location available. Location is just available in conference and meetup. So I know that now location is available, and I can. I mean, this one particular branch of tech event. Break it again. Then I have the case meetup. That's the last case that I have. And with meetup, I guess I have location, but I don't have price because price doesn't exist in meetup. It just exists in conference. And now for something funny, I break here again. Help me, prettier. The last case that I have is the default case. And with the default case, if I look over event dot whatever, it can't be anything. Event is never, because I already exhausted all possible branches that I have. So now event can not happen. This branch event is possibly an error. So the moment you reach this default branch, since you exhausted all possible variations, event cannot happen. I narrow it down to the last possible thing, which is no valid value. Here I can throw an error. This is the only thing that can happen here. So this is how navigating in the type space works, and we can make good use of that. So here I defined again all the event kind properties. So it can be conference, webinar, meetup. And let's say I want to create a type that is called grouped events, because I need that for some processing. A grouped event is just all my conferences that I'm organizing, all my meetups that I'm organizing, all my webinars that I'm organizing, and they are all tech events. So this is what they are about. This is, again, way too much maintenance for me, because the moment I add a hackathon type over there, I would have to maintain another hackathon type. So this is type hackathon. It's tech event base. We just do the same thing. They happen at the location. That's all I want to have for now, and they're kind hackathon. Then I would have to maintain hackathon here at the list of possible tech events. Hackathon, alrighty. Then I would have to maintain the event kind again. So this is, then I have to add hackathon here as well. But then, I'm already prone to having typos, stuff that doesn't line up. So what if this kind up there on line 62 doesn't work out with what I have here on line 81? So there's a lot of maintenance, and I have the possibilities for error. So what I could create instead is a so-called mapped type. We did that again. So we did it already. So I would say for all, this is just that, for all possible kinds that I have. So this is K in event kind, but again, I have some maintenance to do here. So I say just all possible tech event kind. So I'm accessing this one particular property, and you can already see from the autocomplete that it can be webinar or conference or meetup or hackathon. Create a tech event array. So this is the first thing that I would do. So now I have grouped events, and you can see it rolls out very nicely, just in the same structure that I had before. But actually, if I'm serious, this is wrong. This is not what I want to do. I don't want to have every tech event in conference. I just want to have conferences there. I don't want to have every tech event in meetup. I just want to have meetups there. So I want to have those concrete events that I want to that are actually possible with this kind. And I can do something really, really nice with that. I can use one of those built-in helper types that is called extract, and I pass it the tech event union type along. So first of all, get rid of event kind. We don't need that. And then here I pass the tech event group along. So this is webinar or conference or meetup or hackathon. Okay. And then I say, please extract from this union the one thing that comes close to kind of K. So K in that case is either conference, meetup, webinar, or hackathon. So I extract this one particular event and then create an array out of that. And grouped event suddenly becomes conference, become all the conferences, meetup become all the meetups, webinar become all the webinars, hackathon become all the hackathons. So this is just with a couple of lines. And this is something where I say, okay, that's really, really nice. The only thing that I have then to maintain is this particular union type. So I remove hackathon again from this list, and grouped events adapts itself to it just the way it should. So this is something that is really, really nice. The extract type, if I have over it, is a so-called conditional type. So this is where the functional programming language of Typescript comes in. I ask, so if you think set of types, I ask if this type T that I pass in extends the much, much bigger type U. So what it gets is it gets all the unions, webinar, conference, meetup, hackathon, and then it checks if this particular webinar, for example, matches with kind of webinar. And since kind of webinar is a much, much bigger type than this one smaller type webinar, it can say, okay, this is true, and then it just returns T, otherwise it says never, and with never, I can filter out not possible types. So for every event or for every kind that I have here in my keys, I can really filter out this one particular branch of the union type. I'm still not happy with that. There's still something that bugs me, which is it's not conference, it's conferences, okay? It's plural. So please let's do something about it. And that's also very nice. So I go over all those keys in tech event and I just say, okay, this is S, and then I add a string literal. So just like you would write the string literal in JavaScript, but in the type space where I say, okay, this is K. Sorry, typo. So I create the string out of this particular key with S, and suddenly if I hover over grouped events, it's conferences, meetups, webinars, hackathons, I can rest in peace. So this is exactly what I wanted to do. Okay. And again, you know, what we didn't maintain any types at all. We just had to maintain our models. And this is something that we want to maintain anywhere. This is the data we think about. Other than that, we just define behavior so that we want to have group events. This is just behavior defined for those types. So grouped events cannot exist without what I defined in tech events. So why would I maintain all those types all the time? Okay. That's this example. I still have one more. I have to take a look at the time, but I think we are good for one more example. And this is also something that you know, I've seen conditional types and string literal types, and we talk a little bit more about that. I don't know who of you has written Express apps like this Node.js JavaScript framework. But what you see in stuff like Express is you have an app, an Express app, and then you have this HTTP method where you can add a route and pop something up. Never mind. Where can add a route, and this is a parameter. So instead of API/user, you have API/user/1/2, or my Twitter handle /that parrot, whatever. So this is a parameter, and usually this is the function callback. And with the function callback, you can then access this user ID. And usually if I would be in strict mode, which I'm not right now, this user ID would throw an error because nobody would know that, first of all, request has params as property. Nobody would know that it has user ID. So this is any. This is any. Everything is any. This is again Michael Jackson style development. We don't want to do that. One thing that I can do, which is something that you see a lot, is you know, maintaining your generics. So I could say path is a path whatever. I have here callback. So the callback is of type callback T. I just added here callback T. This, which is a function type. Callback. Let's make it like that. I'm getting to that in a little bit. Which is a function. The function has a request argument. The argument is of params T. Params T here is just an object with those parameters where you just spread out the property that you pass. So I can add a generic here as well. And first of all, the one thing that I get an error because suddenly request is params of unknown. So params is unknown, but I can cast it to a particular type. So I can say, yeah, I know the properties that I get are user ID and user IDs of string, and suddenly user ID is available, and I can map this user ID to the one user ID that is there. But hey, that's not what I want to do, because what if after all my users I get an order ID, or make it like that, order ID. I would then have to maintain this type as well. So, okay, it's an order ID and it's also a string. And then I can add, order ID here. This is way too much maintenance for what I want to do. Why do I have to specify the type in here if I can see it from this particular string? Every information that I need is in this particular string. And this is what we're going to do right now. So this is the one thing that I want to show you last. Let's move all the types. Let's think about what we want to achieve. Remove all those unnecessary typecasts. So one thing that you have to know if you work with TypeScript is how TypeScript works with generics. So of course I can explicitly specify a type variable for this particular generic, where I can say, okay, callback is of this particular type and params is of this particular type, or I can let inference work for me. So if I have a function foo that accepts a type parameter t, and then I have p, which is of t. Let's do it like that, and let's return that type. So this is basically the identity function, identity function. Okay. What I can do, of course, is say, okay, const c is identity, and then I specify the type. It's string. Yes. Then c becomes string. Funny thing though, if I remove that particular typecast and just add string, the code works just the same, and TypeScript can infer from this value that I pass in the correct type. And in that case, it's yes, it's the literal string. Yes, it's not all the strings. No, I didn't pass all the strings. I just passed one particular string. So I know exactly that from all the possible strings that I have, I just have this particular string that I passed there. So the type is narrowed down to this one particular string. And I can make good use of that if I look at this signature, this app.get signature, because here I have one very particular string. I have the string of this one particular path. So I can narrow it down to this one particular string. So the moment I define p here, let's say extends string to be a little bit clearer, I say path is p. So the moment I add a string in there with app.get, I know the exact string in my type system. And now I can work with that. Now I can create, for example, a type that is called parse route params of t, where I work with string literal types. And this is where it gets really, really funny. So I can say, what if this one string that I pass in, let's be a little bit clearer. Don't call it here, let's call it path. What if my path extends a string literal that starts with with any string that is available, but then suddenly has one of those params that I have in Express, and I say, okay, I know that at some point this character string comes. So those two characters, this substring is coming up. If this is true, then please infer the string type that comes in this particular place. Infer this one particular thing, user ID, for example. So if this condition is true, I create an object that's called params, and which is of type param. Okay, let's make it like that. Otherwise, I return the empty object. Okay, so I then have to change the callback signature, callback of t. How did I do that? Callback is of, no, I changed it here. Rec is pass route params of t. And with that, let's see if I did it right. Callback of p does not exist in type user ID. Params is user ID. Okay, I have to create the map type. Sorry about that. That's the perils of live coding. I have to create, of course, I have to go over all params that I can infer, and I say it's string. That's how it works. And suddenly, yeah, params has this one user ID in there. So if I change it to, I don't know, just user. I get red squiggly marks, user doesn't exist anymore, but I can add user. So this, the string that I put in there directly reflects on the object that I have in here. That's not all, that's just for one particular thing. So I can have multiple arguments there, like orders, order ID. Okay. And what I have to do then is just making a much more elaborate string literal type where I infer the rest. And if this condition is true, so if there comes more, if more is available, what I do then is, yeah, basically just the same, like here. But I also say, okay, not only that, but I go recursive. So I just, with the rest that I inferred, I just do the same thing again. Okay, this should work. That's the other case. And then I have exhausted all my cases. And look at that. I have, nope, there's an error. It's user and it's params of string. There you go. It's order ID here as well. And if I change that to order, yeah, there you go. And if I add another one, I have add another one here again. Okay. Yeah, there it is. Something to debug. I guess, oh, I have an error up there. Params cannot be used to index type password params. You know what? That's the type where I just make a little peek on how I solved it previously. I guess I just got rid of everything that confuses me there. It's basically just the same, but what I get in return, that makes it a lot easier. Sorry about that, folks. Yeah, user, order, add another one, just what I expected. Very good. So I just moved out the whole params thing into something else. Makes it a lot easier. But what happens here? So this is the fun stuff. So this is the first condition where I infer the param. We have seen that, and then I infer all the rest if a possible rest is available. And once this possible rest becomes available, what I do is going recursively into the same type again. So those are recursive string literal types. This is possible. Just blows my mind. Where I just work with the substring. So I can infer this into param, and then I can infer this piece into rest. And with the rest string, I do the same thing again. Then I end up with order, and then I just take on the rest, and so on, and so on, and so on, and so on, until I reach the condition where it's the empty object. And with that particular thing, I can go over all those params that I just found out, which is basically just one literal value, and then I iterate over all those other keys that I found out. And with that, I can construct this beautiful big object of arguments that I have here. And yeah, I basically have proper typing for all my express scenarios with not that many types. So I didn't have to maintain any types. I can write express apps just like I'm used to, and use this utility type to figure out all the other types that I need. And I think this is very, very powerful. And I constantly see the chat popping up. So either there are tons of questions or I don't know what's happening. I'm really curious in looking into the chat. But hey, this is low maintenance type development. There's 3 steps to it if you want to have low maintenance types. First, model your data. You have to know how your data needs to look like, either by creating a type on its own or by using typeof. So typeof is a tool that I use all the time, which I love a lot. Highly recommended. Then model your behavior. You have generics, you have conditional types to model all the transformations that you do within your functions or the data that you expect. You can model that by using one of those generics and conditional types. And then think a lot about binding your generic. So the moment a generic type variable takes on an actual form. So you can do a lot, and I mean really a lot, by just passing arguments to it and working with the string, with the literal type. It can be a string literal type, it can be an object literal type, without explicitly specifying generics. I know in Angular you have to specify a lot. So I haven't written any Angular code in the last year, unfortunately. But I know from the past that generic type influence was not Angular's friend for some libraries. I guess it was for all those RxJS bindings. I couldn't tell anymore. It has been quite a long time. But if you don't rely on that, with generic bindings and inference from generic bindings, you can do a lot. I talk a lot about that stuff in here. So this is the shameless plug. After I swarmed you with 40 minutes of type system stuff, you can read much more in this little book. And with that, I want to say thank you very much. That's all I have to share for you today. If you have any more questions, feel free to ask him right now, or hit me up on Twitter. I have the worst Twitter handle in the entire world. It's called @parrot. But I honestly, and this is something that I always did, if you have any questions regarding that stuff, and if you have any problems creating stuff like that, ping me on Twitter, send me a TypeScript playground link. I happily try to figure out what your typing problems are, and if you want to create an elaborate type, how you should approach that. The only thing that I take in return that it might end up in a blog post at some point in time. So yeah, that's about it. Thank you very much.